we have iRODS, and they're going to do research community requirements drive, expanded scale, data management features. So we'll let you get plugged in. Let us know when you're ready to go.
Side. See how this works.
It likes me. I'm the special one.
All right. So
I have the magic.
maybe.
Do whatever makes you feel comfortable.
Maybe we'll do it from down here.
Okay. The only downside, well, actually.
I can just reach out to the buttons.
Okay, and you're lit up and ready to go.
We'll see.
Happy? All right,
I think so.
welcome. Okay, everyone. iRODS is ready to go, so take it away.
All right, welcome. I'll take my mask off here. So I'm Terrell Russell. I'm with iRODS, and today I'm going to be looking, I guess, down at my laptop or up at the screen, talking about research community requirements and the fact that those drive the feature sets that we have been building for many years and the things that are out there now. So iRODS is a project, consortium even, under the Renaissance Computing Institute at UNC in Chapel Hill. And we've been around for a while, and I'll tell you a little bit about that in a second. So our mission really is about a sustainability model around this piece of software. Our goals are continuous improvement, to continue to grow the community and relevance, and then to start to standardize the things that we see in the community, and then, of course, continue to show membership value of being a part of this community. So we've got about 30 members, I think, right now, and these include people doing science, different storage vendors who want to remain maximally compatible with what we're working on so that they can sell into those places doing science. And then we've got technology integrators and partners around the world as boots on the ground, maybe doing tier 1 support because we are not that big and we are at a university. So we do this in the open and we do it with lots of friends. And so going through these 4 things today, I'm going to tell you a little bit about where we came from, the reasons why we do it the way we do it, talk about that process, because I think that's the main takeaway for today, and then, of course, some of the results that have come out of this. So we did begin this journey in 1995 when grid storage didn't really exist. Came from the plasma physics community. You start exploding things in the computer, and you can't write them all down on the same disk, so you have to write them down on many disks. And that was very interesting to funding agencies at the time, and they gave them about 10 years of funding. Turns out you solve the problem, they don't give you any more money. So the next problem became we need to add a policy layer to this. So in about 2004, because of some licensing questions and things, iRODS was started, and it was effectively SRB again, but then with an additional policy layer, a rule engine. And then in 2013, that money started to run out again because the problem was solved from a scientific perspective. And so NSF and DoD and DARPA, and they all started having this opinion that we should start paying for ourselves. So we created this consortium to continue longevity into the forever. And so that was started by RINC and then the DICE group that had been running SRB and iRODS itself. And DDN was our first consortium member at the beginning. In 2014, the consortium took the code base, kind of took the baton from the DICE group. And so since then, we've been off and running. And the goal of that was to basically take a science experiment and science project and turn it into production-ready, enterprise-quality software. And so that's what we've done. And people do need this. They have lots of files all over the place, all kinds of existing technologies. The really smart people who don't work there anymore made lots of decisions, and now you have to deal with them. You will continue to make brilliant decisions yourself, and those will be different, and you need to integrate all those. So all these things are important, and as the organization and the data obviously becomes bigger, people come to us. So we sit in the middle. We can talk to pretty much anything you've got on site, anything that you haven't got on site, anything that you will have on site, or in the cloud. And the idea is that by having control over these accesses, comings and goings, we can make very strong claims about the types of things that are happening in the system. I'll talk about that in a second. So we do 4 things well. We abstract the data itself. We can talk to any kind of storage because it's a plug-in architecture. The plugins are the ones that are in charge of the coming and going to the disk, to the tape, to whatever it is. We have a metadata catalog that is fully abstracted. It obviously collects lots of system type of metadata, but also any type of arbitrary user metadata. These can be both descriptive and prescriptive, so you can talk about what's already in the system as well as what you want to have happen to the system. And so with our policy engine that was added, we can have hooks into every operation into the entire system, and arbitrary code can be written, policies can be designed, can be strung together to do interesting things, and that gives us the power that's going to show up in the next couple slides. And then because, of course, it's open source, this is BSD3, C++ client server, it can federate with other instantiations of this software, which means that it can scale to whatever you need to do, and then the organizational boundaries are the things that define the scope of the zone that you're working in. So you can work with different departments in the same company, you can work with other research institutions, you can work with subcontractors, you can bridge these divides with policy and permissions. People can cross the border into your house. Your policies fire. If you go visit them, their policies fire, and they don't have to coordinate ahead of time. You don't have to find common buckets of money to work together, and you can tear it down when you're finished. And so with all these kinds of policies can be stitched together, we've heard from the community these 8 things are what they want to do, right? And so by stitching these things together in a certain way, we can provide packaged policies already available. These are the things that people want. They can put them on the system. They can configure them. They don't have to write the code, worry about the edge cases, the funny characters, all that kind of stuff. And these are derived from what we've heard from the landscape. And so most people show up, they want automated ingest and storage tiering kind of out of the box as soon as they're big enough to need something like this. And then because that's done and it's available and the system works and the platform's available for them and it's flexible, turns out, well, we'd like to do some auditing. Maybe we can get into some compliance work. That turns out to cost a lot of money when you have to pay the lawyers to come and assume things and make statements, right? So it starts to pay for itself very quickly. And so a little bit about why we do it the way we do it. So this really is part of a 100-year view and a conversation around that. Again, it is a plug-in architecture, so that means that the core can be nice and generic and boring and safe. It's really about doing bookkeeping well and having an API that's stable and standardized. But the plugins are where the action happens in terms of talking to specific technologies or doing specific things with rule engines. And so once you've got policy and you can stitch it together, it becomes about a composition exercise. And this is a computer science concept that we've taken and put it right into the architecture. If someone shows up, us or you, and write a new plugin, by nature of the architecture, every operation in that plugin will get a pre and a post hook, a policy enforcement point. And that means that you don't have to worry about those dark corner cases. They can be automatically audited in the same way that everything else was already audited or included in your analysis. And so we've taken a code base that was originally started in the mid-90s and 2000s, and we've modernized all the internals. We've now up to C++ 17. We've got really nice things. The bugs are gone, and it's really solid. And again, this is all about configuration, not code. So we're here for the flexible future. The process itself is handled all in the open. This is all open source. We've got a Google group. We've got 100-something repositories in GitHub, various different projects started and handled by different people. And then through a process of having open working groups with monthly meetings, we have these conversations in the open. These, again, are also in GitHub. And so this is pretty small for a projector, but maybe those of you in the computer can perhaps read it. So we've got a standard technology working group where we just keep everybody abreast of what's going on, what people are working on. A metadata templates working group, because if your metadata is not any good and it's not coordinated, you're not going to be able to find anything later. You have to have this stuff be clean and consistent. We have found that the pharmaceutical companies are head and shoulders ahead of everybody else at this because they've been doing it for so long. They have to use the same words to describe what they're doing, or the other groups can't use the data. Authentication working group. Authentication's changed dramatically in the last few years, and so this group was spun up to do some work into making things a little more flexible, and that work is actually going to be merged. It's actually complete, and we're going to merge that into the main branch and kind of take over for our existing authentication scheme. But the API is not changing, which means that everything that's been written in the past will still work, but the new architecture will kick in pretty soon. In our most recent one, we're hearing a lot and getting a lot of interest from people doing microscopy, right? Like this is, the images coming out of these systems are getting bigger, faster, more detailed, and they need more automated processing. It's just not sustainable the way it is. And so some standardization has happened around different tooling. And so we're going to try and plug in with Omero as our first exercise and make it so that the Omero universe can tie into the iRODS universe. And then all of a sudden, all the tooling that you may have in the rest of your organization can now have raw access to the information coming directly off the instruments. And of course, when these things get ingested, all the metadata can show up as well and make it immediately actionable. And so all of that has led to a few things. I think I've got about 8 examples here. In the last year, the ones that are bold have new releases, but we've got a bunch of things that happen in the server, that's the plugins, and then we have a bunch of stuff that happens outside the server. And so it turns out, now that the core is a bit more solid and robust and modern, the action's happening kind of out on the edge, which is good. It's what we want to see. So in collaboration with Bristol-Myers Squibb, we worked on and developed an S3 Lambda function, which allows you to keep up with any arbitrary data dropped into an S3 system. And it doesn't have to be necessarily Amazon. If you've got an equivalent to Lambda in another vendor's S3 implementation, that still works. But whatever system it is, Internet of Things or cows or cars or drones or whatever is dropping data into your system, we can keep up, and all of a sudden it becomes actionable to all the tooling that might be behind that policy layer on the right side, or any other user of iRODS. Our automated ingest is a scanner that keeps up with parallel file systems, and that's impressive on its own, but because it ties into the same framework, all the benefits that you get once things are inside the policy boundary apply here. And so working with Roche, we were able to develop a nice generic solution for this, still very flexible. Storage tiering was also developed alongside Roche. They had a need for this metadata-driven abstraction around the types of storage they had, and so this works because of the abstractions that hold with our storage already. This is just a layer, and you take action on the things, and the default query is based on time, but the query itself can be overridden, and you can use any query into the system to determine whose time it has come to move to the next tier, right? And there's benefits in terms of capabilities in terms of keeping things around on different tiers, or making sure it doesn't go all the way back out to the microscope, right? Like you don't want it to go back to tier 0 because the tier 0 was the Windows box that had the microscope on it in the first place. So very flexible. Indexing itself, enterprise level search may already involve an Elasticsearch database or a Solr database or multiple of those, right? And so this allows a little sprinkling of metadata, and obviously at that point the jobs wake up and can be indexed to the flavor of technology of your choice, and that can be full text or metadata. That was with the NIH. We've had customers, clients, friends develop different GUIs, and so this one was actually developed by EMC before they merged or got bought by Dell, depending on who you talk to. And so they contributed this UI, and this is now our best of breed UI. Since they've done this, we've embraced it and cleaned it up and got rid of some of the assumptions they had to make because they weren't in the room with us. They were just outside, so now it's a bit cleaner and more robust. Cyvers is a project out of Arizona, and we've already got client libraries in Java and Python and C++. They've gone and developed a full-featured, complete API solution for Go, which is very nice for those people in the Go community. And they are about to roll out an update themselves this spring. And all of their tooling and all their back-end cloud work and their discovery environment for 60,000 scientists are going to be powered by this very shortly. Research Computing in Boulder was very interested in having iRODS present as NFS. And so this file system integration exercise was something that we thought was very interesting, and so we worked with them to provide a generic solution, right? It doesn't have to be tied the way that they needed it. And so along with them, we worked through the specifics of how this would be designed and work, and in an enterprise space where you're in control of the users and the Active Directory or the LDAP or whatever, this is a safe way to present iRODS and all of its multi-user ownership and permission models and everything through NFS v4. This includes v4 ACLs, so you can do that as well. Most recently, we've had a couple press releases out with this. Working with Fujifilm, we've added the Glacier capability to the S3 plugin. So if you do have what tape companies call a tape gateway, also known as object storage, then this might be the way to go. So they've got a product where they present as S3, and they have a short-term object store in front with all the tape you need in the back, right? So this is something that allows us to work with Amazon as well. It's the same interface, same verbiage. And the last one here, I've been working with Globus for a couple years, and they've now got a plugin architecture on their side, and so we worked with them to provide an iRODS connector. So if you're a Globus customer and you've got collaborators who are iRODS users or vice versa, this is a nice way to be able to span those. And we don't care how the data moves. This is just another data mover, and so that's good. I think that's the last slide. Yes. So our assertions here are that if you want to do this the right way, you've got to have policy enforcement. That's the only way to do this as a grown-up, right? You can't do this willy-nilly or in the wild, and you also must expect and assume that these policies will change over time. Or you're going to have a tough day one day, right? These are the realities of our job. So with those two caveats, we think that open source is the right way. If you've got that 100-year view, this is the right way to do it. And that's what I've got to say. Thank you.
Any questions out from the audience?
With or without a microphone.
Questions? Oh, there's some stuff. Here, the one came through the Slido, so hand it to me. Check. Okay. Hello. So someone did ask online, actually, probably a nice, easy one for you, and that is that they're very excited about what they were watching, and they wanted to see if any of this information will be available on your website or any details and stuff like that about this presentation.
That's an easy one. Yes. Everything we do is in the open, so all of our slides, all of our trainings, all of our documentation, links to code is all at iRODS.org, github.com/iRODS. iRODS.org/documentation has a bunch of those one-pagers, the images that you may have seen in a few of those slides. So absolutely. And if you have something that you'd like to see, please find me. It's easy. I'm on the internet.
Thank you so much. Anyone else? Well, great. I really appreciate you.
Thanks.
Thank you, iRODS, for coming on.